Eric. The agenda for tonight is to kind of share how to get started with programming, where to find the application in your Nspire software, and we're going to kind of look overall at how programming works, how to get input from the user, how to provide output to the user, and I was going to share some sample programs, and then we'll look at a little more advanced programming with how you can use the language to create decisions and do things repetitively. And then finally we'll look at looping so that you can have programs that do a lot of executions automatically from there. And so we hope that by the end of this session, the outcomes will be that you'll at least be able to use some basic input and output statements. I think the famous one that if anyone's taken a programming class is to get your computer to say hello world. So that, that kind of basic level, but then also understand how programs can make decisions, include repetition, do looping, and just the overall structure of it so that you're at least comfortable enough and be willing enough to kind of play with some of the additional resources that we have for you at the end of this. So at this point, I'm going to turn it over to Doug, who's going to walk you through some of the basics, and I'll be interrupting from time to time to ask Doug some questions on your behalf or get him to clarify some things as we go through the evening, and I hope everybody enjoys it.
Great, and as we're closing the poll, I just want to make a quick note about the duration of this evening's event. We've advertised it as 45 minutes. We know that we have a lot of people online joining us, so we want to make sure that all the questions get answered. So we're kind of shooting for 45 minutes, but with the expectation that that there will be a lot of questions at the end. However, the event will not exceed an hour. So we do want to respect your time because it is a weeknight. So I'm going to go ahead and turn it over to Doug.
Hi, everyone. I'd like to thank TI for hosting this event and Eric for setting up all the webinar stuff, and Dan, my partner. If you like what you see in terms of the examples, all of these examples will be online for you, and we'll have information about it, and also a 5-week program or a 5 one-hour lesson that you can take if you wish to learn all about programming. Obviously, tonight we can't teach programming. We can show you some examples, and if you are really a good programmer, you could say, well, I'm off on my own and I don't have any problems, so this will be good for you. It's my hope that TI will continue to improve the capabilities of this programming language we have, which is procedural. And if you've done some programming on the 84 and the Voyage 200, you probably have a little bit of a head start. What I want to do to get going here is to show you just an example of how to start a basic program. And I'm in the emulator, and if I click on a new document, the first thing it asks me is what application I would like to add. In order to write a program and have it in your document, you need to add a calculator page. So if I add the calculator page, you see everything you would normally see here with the calculator page. And remember, you can program on the emulator or a calculator. I would suggest doing it on the emulator because you can type fast and you can copy and paste a lot easier than what you can do on your little calculator. But if you go all the way down to the end of the tools and click on it, you see the very first thing it says is Program Editor, and under that is the word New. And so when you go to make a program, you have to give it a name. And of course, for this one, I'm just going to put the word test1 just so we have it. In this partition, you can write programs and functions. And of course, functions like square root and rounding and everything like that we already have. You can make your own specialized functions if you want, but the program is what we're going to concentrate on tonight. The other thing we will not concentrate on tonight, but you should know, is that you can put your programs and have them in a public library on your calculator, so you can use a program from any document that you're in rather than having to have the program in the document itself. And as soon as I do that, you'll notice what happens is it splits my page into the calculator side that was there originally and into a little program under the name of Test 1 like I had it. And you'll see right away that there's a set of parentheses that follow the word Test 1 that I gave the name of the program. And this will allow us part of the user access input that we want to have for programs. I'm going to write a little teeny program by clicking on here, and the output we have right now that we can use is a display statement. And so I heard Dan mention hello world. So if I type that, I have to put the hello world in quotes so that it would print out as it's written there. And that, folks, is a complete program. Up in this corner up here, you see there's a little asterisk before the word Test 1. That tells you that your program needs to be recompiled so that it can be accessed by your document. And so you'll see now we have a different set of icons at the top, and number 2 has the word check, and this is where you go down and compile the program, and the calculator will check the syntax and make sure that you have everything that it can understand. And up at the top, notice it says Test 1 stored successfully. And then to access this program, I can anywhere in my document on a calculator page, I can type Test 1 and see how it became bold, put the parentheses, and press enter. And it will actually end up showing me my output. Then it executes the program that way. Now, if I want to edit it, I simply go back over and add another line. So I'm adding another display statement. And there's the information inside of quotes that will print as per shown. And then if I put the same information outside of quotes, and notice my asterisk, which means I'm going to have to compile it again and check the syntax. And it says everything's okay, and then I can go back over and type in Test 1 again, or you can go up and copy it down and run it. So there you have your basic concept, and really everybody from here could just play and try things out and be on your own. But I want to show you a series of programs we have written. These programs, again, are online for you, and we'll talk about that later on once we finish. But right now I'm going to start at the very beginning and talk about input and output. So I'm going to look at a first program that uses the concept of input. And this one is using input that comes from the between the parentheses, and these are called arguments. And notice in my call to the program, this 2-point slope program, I've got 1, 2, 3, 4, the numbers separated by commas, and if you look at the program, I have A, B, C, D. Now, I think most of you know that in a document, if you have a variable, it is global to your whole problem, every application within one problem. And therefore, if you don't have any other way to do this, these are therefore designated as local variables, along with this one called slope I have down here. If you, this is a command, local, and it's slope. So what I'm going to do is run the program, then we'll talk about it just a little bit, and you'll see what happens. Well, notice that 1, 2 became AB, 3, 4 was CD, and I computed slope based on the fact that the person put in 2 ordered pairs that would, therefore, a line would go through those points, creating a slope. And then I have all these display statements that produce the information you see on the right. And the nice thing about this is we can, once we've written the program and executed it, I can go back and change the input to anything I wish. So I'm going to put in 1/2 and 2/3 and -3/5 and let's say 4/7, just to be different. And look at the output. Remember, the Inspire has this beautiful, pretty print that it has, and therefore those fractions stayed fractions and printed out. And now it looks really cool. And you can see by writing a program, you can automate a process so that something that you're going to be doing over and over again can be done by a program instead of by hand or by having the calculator figure it out step by step. And so if it was a process that you wanted to have, you could write a little program or have your students write a little program that would automate the process for you. And if they can write the program, they pretty much understand the concept of slope in this case, which is what the program does. Dan, do you have any questions?
No, sounds good.
Okay, so that's what we have is our very first, and by the way, this is what TI had is their very first way of interacting with a program, and that was by using arguments. And these numbers was the only way in the beginning to get information into a program so that the program could actually take the information and execute it. So I'm going to go on to the second one and show you the new way, the new language added to it this last year. And now the computer programming allows for input via request statements. And let's take a look at this one. So I'm going to just execute the program. Notice I don't have any arguments, which means I'm not sending anything to this program over here in an argument. If I press enter, the first thing that comes up is a request box, and this is how they're getting around it right now. They're putting a box on the screen that you can input any number you wish. And so right now I have the number 2, the negative 2 as a slope. And if I press OK on that, it will ask me for an x-coordinate, and I put in numbers ahead of time, which I can change. Let's say I'll change that to -2. So the x-coordinate is -2, and the slope was -2, and the y-coordinate, let's make it a 5. So I have the ordered pair -2, 5. And you see now the computer took that information, and as long as it was programmed properly, a slope of -2 and an xy point of -2, 5 would produce a linear function, y equals -2 times the quantity x minus a -2 plus 5, and then it simplifies it down. All of this is done by the programmer and not by a CAS operating system or anything like that where it's simplifying it. That's all being done by the program itself. So here's the story right now. You have 2 ways to get input into a program, through arguments or through this process called request statements. And all of these variables you see over here are global variables, and I'll show you what I mean. If I simply type in the word slope over here, notice how it turned it to bold, and if I press enter, it shows me. In fact, if I would have other pages within my document, I could refer to that same slope, and this will become valuable. There are times where you want to have a variable that is local to only the program, and you want to have other times where you want the variable to be accessed at other parts of your program, and this will become self-evident later on. So right now we have a way to get input and output into our programs, and I'm hoping that there will be other methods for input later on, but we'll just have to hope because it's not there right now. I'm going to go to a... Dan, go ahead.
Recap for a second about setting up the programs is that you started with a calculator page, which is what's on the left side of your screen, and that's where you're typing in the name of the program and all of the results are showing up. But to actually access and write a program, you had to go into the function menu on the calculator page.
Yes. In fact,
and that's how you set everything up.
Yes, if you didn't know about programming and you were writing a program, notice they have all of these tabs at the top. And if I press I/O, input output, notice they have the word display, the word request, request string, which we'll talk about, and text. Those are your 4 input outputs right now that is available to you. And that's what we were using in this program. And if you want, they're going to record this session. You can go back over it again and look at that very first little simple example. By the way, I just did something there that you might have noticed. If you're in the emulator, you can hide your program over to the side if you wish, or you could hide the input. It's all according if you want to have lots of room for programming or lots of room to look at the output of yours, but it's done very simply there. It might be interesting for you to take a quick look at the view of the handheld. This is what you see on the screen here, and I can do the same thing on the handheld. I can pull that variable window back and forth according to what I want my students to see at the time. But in programming-wise, it doesn't work so well.
Yeah, and there's certainly advantages of using the request command for input versus the arguments, because if you're using the arguments, you've got to know pretty much how many you're going to have before you start the program, or at least have an idea so that as you build it, you keep adding in more and more arguments, and you kind of need directions for the user if you're using that argument approach versus the request approach, because the request approach allows you to type in some sort of direction so that the user knows what they're supposed to input.
That's a very good point. And if it wasn't for the fact that we had the request statements, the program actually would not be dynamic. In other words, ever changing. So that's a very good point, and I'm so glad that they add the request. I don't like the look of the request statement. If I run this same program again, just real quick, because we want to get to other things, but in the handheld form, if you look what happens on the small screen, which is on your calculator, if I go over here and run that program again, go back up to the top, notice that the request box shadows over the top of your screen, and therefore, if you have important information behind that request box, then you're in trouble, because you're not going to be able to see that until you remove that request box. Let's go on, and you'll see more examples, and everything will start to fall together a lot better for you. One thing that's going to be important in programming is to be able to have a computer make a decision based on the program, and then do things based on that. And I wrote a little program here that is very simple, but allows for decisions and for repetition. And basically, this is really almost like the Price is Right game on guess what the price of this item is, but you're guessing a number from 1 to 100. And so I'm going to run this program, and I've got it hidden right now so you can't see it. And I'm going to use Dan as my guinea pig. And notice it says guess a number from 0 to 100. Dan, give me a number you want to input.
We'll go with 50.
Okay. And it comes back and says that 50 is less than the answer it's thinking. So give me a second input.
75.
All right. In this case, notice that the output is hidden. And I can move my little request box in this case, but it says that 75 is still less than the answer.
88.
Still less than?
95.
Bingo, yes, that was my number. It took you 4 tries. And I think there's something in the program, if it takes you more than 8 tries, it says that you don't know how to play the game on Price is Right. So let's take a quick look. Notice that there was decisions made there, and it gave out information based on his answer. There's something that's going on here that's very important, and I think there was a question.
Oh, yeah. Before we look at the structure of the program, I just wanted to clarify to participants about the floating toolbar. We're receiving a lot of questions, but I just wanted to make sure that people understand that the floating toolbar, it's generally in the lower right-hand part of your screen. So once we're looking at Doug's desktop, as we are right now, to access the chat feature, you click on it's like the dialog box, like you'd see in a comic strip. So I just want to make sure that everybody understood that. If you click the dialog box, it'll bring up the chat window, and you can send a question to us. Thanks, Doug. Sorry.
No problem. That's great. In fact, we're going to, Dan and I plan to be here for you until our questions are answered at the end, and everybody else can leave when they want. I want to bring up something very important, and that is in this program, notice as it uses a random number generator that you're very used to, the random int. Here's the problem we have right now in the programming. Every time I use the emulator, the random number generator goes back to the exact number of seed that it has. And you know and I know you can change that. There's an actual command where you can type in a seed, but what you're doing is just going to another point in the random number list and having it start at that location. I knew the answer to this problem before we started was 95 because when I brought this calculator back up, I had not used the random number generator, and I knew that the first problem in this test was 95. Now that won't happen on your calculator as much as it does on your emulator. On your calculator, once the kids start doing things that involve random numbers, that can continue on, and it's completely random for the numbers they get. So in this statement up here, I'm doing an assignment statement for the variable x, and right now, notice that there's no place in here where I mention the word local. Every variable you see inside of this document is a global variable to the document. You need to understand that if you don't want to get confused, if I use x in here, if I use x over here, that x you see is the x from the program. And so that's a very important point for later on when we run programs. Anyhow, notice we have this new thing called an assignment statement, which you know, some of you might know from just doing calculators where you're assigning variables values. But then there's a new statement here called a label statement. And this allows me to go back to a point in my program and re-execute what is below that label. So notice I ask for the guess between 0 and 100, and they put it in. And then I again record the number of times they've tried the problem. And this is very calculator, computer-oriented statement. 1 plus the old value of tries is now going to be stored in the new values. Now, I can't do this with every program, but I thought I'd point out just a couple things for you, because this is the first time we're doing an if statement. And an if statement is used to make a decision. And in this case, notice I'm checking their guess against the value of x, so I can display either it's less than the answer, or in the next one, down here in this one, in this statement, I'm checking to say it's greater than. Of course, if it's not less than or not greater than, it's equal to. And that's why there's not a third if statement, because it would fall down to this part of the program. And notice here, there's a word go to start, and that's the clue to the computer to go back up to the label and start going back down through the program again. But all these things will become more evident if you decide to program and you want to listen to our lessons where we went very specifically through everything you see here. But now you know that you can make decisions and you can repeat processes as many times as the user needs, or in this case, until he gets the problem right, which may be frustrating for some people, but it worked for us pretty good. We're going to take a look at another example. And this is using, again, the capabilities of the computer to interact with the user. And this is called the slope test. One of the things that I'm trying to work on right now, and as some of you know me, I have written a series of mastery tests for Algebra 1 on the 84 calculator. And I'm trying to start programming the Nspire calculator to do mastery tests for the Nspire as well. But also, and I'll show you, I might have a chance at the end to show you a program that goes along with an action consequence document, if you know what those are, from TI. So let's take a look at this program. This is called slope test. And I think you see right now, you can't see any program over here. You can't see anything. So I'm on another calculator page that isn't where the program is stored. And up at the top here, these arrows show you if there's more coming and more behind in your program. So I press enter, and it says, given these 2 points, is the slope undefined, 0, positive, or negative, or none of the above? Well, that'd be interesting, how it could be none of the above. But anyhow, I guess it could just be the same point. So then over here it says enter 1, 2, 3, 4, or 5. Now you know the importance of being able to see this information behind this request box that is there. And just off the top of my head looking at this, as x goes from 4 to 14, y is going from -2 to -12. So I think the answer is negative. So I'm going to put in 4 for negative. And it says Great. Now, what is the slope? Well, now I got to do some calculations, and I don't know the answer, and I'm not going to take the time to do it. I'm going to put in the number 3. And what does it say? I put in 3, and it says, sorry, the slope was -1. And it says, do you want to do this program again? In other words, it figured out a slope, it figured out the points, it figured out what the answer was, and then it compared my answer to the answer that it knew was true if the program was written correctly. So I'm going to say, no, I'm not going to do it again. But this is a good example of how a teacher could have a program that the students work at their desk and answer the questions, and when they finish, notice it gives how many they got correct and their score on the test. And of course, I got a 0 because I only did one problem. But that's the kind of programs that I like to write for the students, so that the students have this Game Boy mentality in their work in mathematics, so they're not frustrated if they don't get it right the first time. They can continue to work on it. So I'm going to go to the next page where the program is. And up here, notice I have the word local. That means every variable listed here. And what's nice about the Nspire is you can use real words instead of just A, B, C, and D for the variable names. And that means every variable listed here is only known by the computer. So if I would go back a page and I type in the word winners, which is one of the variables, I must have an external value to that, or it must have been loaded, because that local means that the computer doesn't, the rest of the program doesn't see it. So we'll have to check that. I might have to recalculate that. But there's some random number generators in terms of finding points, and then here's the program with our display statements and our request. But here's a new one. Right here, we haven't seen this before, and it's called a request string. So the information is being entered as a string, and then you have to learn all about string manipulation and the value of string values that the computer uses. So I'm actually entering the number 5, but it's being recorded as a character 5 and not as the number 5.
And so can I just point something out, and I might not know the complete answer to this, but
sure.
Someone commented that some of the words are italicized and some of the words are not. And so the italicized means that it's a variable. If it's non-italicized, it's a command that the programming language understands, or it's a command that is built into the calculator. But also, if you put in any text into quotes, it won't be italicized, correct?
Yeah, exactly. So what you see right here is EXPR. Because it's not italicized, it's a reserved word of either the calculator language or the programming language. In this case, XPR is a calculator reserved word that changes a string into a numeric value. And the string type, though, if you see on the inside, it's italicized, and that means it's a word that I've made up, and it's not a reserved word. And it can be either a variable, or in this case, the word that is for a label. So if you see the word start over, and up here in the label, it's not a variable, but it is my own piece of information that I've made up. And so when you're programming and you want to use a variable, and if it comes up that it is not italicized, that means it's a reserved word and it will never compile there for you.
And the best way to find like all the keywords that the program understands is to probably start by looking through the menus that's provided, right? Because most of them are there.
Absolutely. And you look up here, I have my transfer statements, my go-to, my returns, my label statement. Over here I have my if statements, and if you go to if you start a program and you go in here, it will, this is like a template for an if then else and if statement. All of these will be there for you if you want to use them instead of starting and typing in the word if yourself. It will give it to you. Because we want to continue on and get going, I'm not going to take time now, because you can learn that when we go in and teach your programming in those other sessions. This is a program that was written by Dan and updated by myself, and this is a looping program. It uses another kind of loop rather than a decision loop. It's actually using a loop that will execute exact number of times based on the user desires. And if you remember all about partial sums, I've got information in this document that talks about, so this is kind of a little programming document where they learn about it, and then they go over and they actually run the program. And this program is set up for maybe investigation purposes rather than anything else, so that a student can conjecture how the program came up with the answer. So here's an example. If my first term is the number 1 in this geometric sequence, and my ratio is going to be 1/2, then the next thing is, how many terms in the sequence would you like to see? So I'm going to type in 10 so that we can see them on the screen. And Eric, why don't you go ahead and explain kind of what happened here in terms of all this information?
Oh my word, it keeps going. Let's see, so is it
Yes.
looping?
It's actually looping through, and it gives you at each term position. So the first term was 1, the second term is 1/2 because 1 times 1/2 is 1/2. And if you add 1 to 1/2, you get 3/2, and if you want an approximate value of that, it's 1.5. Then if you take 1/2 times 1/2, you get 1/4, and if you add that to 3/2, you get 7/4. And these are what we call partial sums. And obviously, if you run this again with the same input, I'm going to keep the same input but go to 25. This actually converges to a value. It's hard to see looking at the fraction here, but it's not very hard when you turn it into a decimal approximation of what it's doing there. So this program is set up to run loops, and I'm going to go ahead and show you the program statement real quick. It's a very short program. It's not very big, but it does a lot. And here it is right here. This is called a for loop, that you can actually tell the calculator computer program exactly how many times you would like to iterate the information before the end for statement, which is down here. And everything on the inside will happen that many times. Now, because we had the user tell how many times he wanted to run the program up here in the terms, then that was a user implied value of how many times that for loop was going to run. And so it's still user controlled, but it will do it over and over again without any other decisions. So that's another kind of loop you can use in a program. And this kind of program, I think, is good for investigation for a student if they learn what a geometric sequence is up here in the beginning. I love the Inspire because you can build a whole document for the student to follow and then to execute programs and to answer questions. So it's just another tool. Let's go one step further with this. This one uses the concept of strings. And what I'm going to do is ask the student to take a line in standard form and change it into slope-intercept form. So it says, given 12x plus 2y equals 6, type that in the y-intercept form. So if I type y equals, let's see if I can do this in my head. Let's see, negative 12x divided by 2 would be negative 6x. And then plus 6 divided by 2 would be 3. So if I'm a good mathematician, that's what it's going to look like. And it comes back and says, your answer, my answer, awesome. Let me run it again and miss it. I'll type in something that's wrong. I'm going to put in x minus 4. I have no idea. I hope it's not right. And the computer comes back and said, your input y equals x minus 4 should be y equals the slope times x plus the y-intercept, and the correct answer is here. It doesn't show you exactly how to do it, but it does. It is able to check it. And you're saying, well, wait, how could the computer do that? the reason the computer can do this is because of the being able to take a string of information in, and right here is where I'm requesting the string, and I'm asking the person to type in exactly what they want to type in, and then with that in mind, it will change that answer and tear it apart and look at each part of it to see if the information contained there is correct. Now that takes some time, but I do teach all about strings in the lessons that follow. Now, because we're going to run out of time, I have to show you one more thing. This goes all the way back to the TI-84. This is the little program called Algebra Test A that I wrote for the 84. And I'm going to run the test, and this is where you can add, subtract, multiply, and divide. And I'm going to put in, I want to do all 5 different kinds of problems, and I want to do 5 problems real quick. And it says, what's -2 divided by 1? I know the answer is -2. This time it says, what's 1 plus 5? Oh, I think that's 7. I'm going to miss it. And -2 minus 1 would be -3, and -3 minus a -5, let's see, that would be 15. Obviously not, but I'm saying that. And then finally, -20 divided by -5 is -4. Okay, it comes back and shows me how many I got right, the number possible, and the percentage score. And then it shows me how many, I didn't do any addition problems. I did 1 subtraction, I got them all right. I didn't do any multiplication, I did 2 division, I got them all right. Well, actually, I did 2 addition problems, I didn't get any of them right. Now, here's what's cool about this program. It actually, and this is in the document, I have it all set up, ready to go for the students. I can go over to the next page and actually look at the problems they missed and what the correct answer is and what they typed in so that we can talk about it. That is an awesome thing to be able to do in a program, is to be able to take the document and take the results of a program and look at that. Now, I want you to know that the reason I was able to do it is because I chose some variables to be local and some variables to be global, and those variables were transferred then to this Excel sheet so that I could actually store them in the Excel sheet. And that takes some time, but we can show you how to do that as well. The very last program, this is, if any of you have done the action consequence document called Linear Inequalities, this is a version, a mastery test to go along with that. And it is all laid out with all the instructions and what everything means in terms of a point being above, on, or below a line with examples. It's all ready to go. And after they go through the tutorial, now remember, they wouldn't do this until after they've done the action consequence, but here's a mastery test on it to see if they know what they're doing. And it asks questions. I'll just do one problem. And it asks questions that says, given a point, there's 6 different questions in the program. Here's a point. Is the y greater than or equal to or less than the -3x minus 2? So a student on paper would work out the problem results and figure out if this -14, this y value, would cause this expression to evaluate to greater than, less than, or equal to. And I'm going to put in 2. I have no idea what the answer is. And it goes through and shows the student all of the work so they can see how to do the problem and the answer, and says if they're right or wrong, and then gives their score. And we don't have time to look at the program, but this program is available. Anything I do is available to anybody, and you can just request or go to my website and look at that. So what we've done is we've looked at different kinds of input that we can do, either arguments or with user requests, decision-making processes that we can do, the concept of a little test where the computer's making a decision based on their answers, a looping situation that we can do loops and have something do an iteration so many times, a little test, a bigger test, and then a huge test. So we have all these things available. I'm going to go ahead and stop here and allows Dan and Eric to take back over so that they can explain how you can get to these programming lessons to learn more about it if you're interested.
Let's see. Great. Thanks so much, Doug. I see we've got a couple questions about, let's see, we have one question about the emulator view, right? And we'll go ahead and make sure that everybody remembers how to ask the questions. Use the chat feature. It's now on the right side of your screen. But we had a question regarding the view of your software. And let's see, let's find it. It's Dennis. He wants to know, I have Smart View, but it's for the TI-84 module. How do we get this version of Smart View? Because my Inspire Teacher Edition is not like yours. And
that's right. Let me go ahead and answer that real quick. The TI-84 emulator is only going to emulate the 84, and you actually, it's like buying a calculator. You have to buy the emulator for the Nspire, and they have two versions. They have the CAS version of the emulator for the CAS calculator, and then the numeric one for the numeric calculator.
Great, thanks. And I think that...
Yeah, sorry, Eric, let me just interrupt, because Doug still has control. If he can just share his desktop again, I think I can get a couple questions answered all together that I saw as we were going along.
Okay. I'm back on my desktop.
Yeah. And I'm trying to remember which program would probably be able to do that. There were, one of the questions was about global variables, and I can answer that of just saying that the global variable is for the document that you're working in.
See, Doug?
Yes.
If you go up to Share, the Share menu up at the top of the Meeting Center, and then...
I didn't share my desktop, did I?
There we go. That's beautiful.
So, Doug, just go ahead to linear forms. Yeah, there was a question about the copyright symbol in the program, of putting that in front of a statement.
Right here?
Yeah, that's kind of like a comment that the program just doesn't read.
Yes, and that's actually under Actions over here. It's called Insert a Comment, and that puts that little symbol here. It's not a copyright, but it looks like it, and it's so that you know in a program if you want to write something there so that the compiler doesn't think it has to execute it, then that's what that is. It's just a little comment. And in most programs that are huge, I'll have comments all over the place so I can remember how I wrote the program.
Yeah, and I don't remember if we had discussed this before, but you right now have everything on a different line by hitting Enter, but you could do two different commands on the same line by splitting it with a colon. Is that correct?
Yeah. In fact, we'll just, what we'll do here is we'll just go and make a little teeny little program just to say it. This will be test 2. And if I want, I can say display hi, and then I can put a colon, and then I can have a second statement that does a different output. And then so that you can actually, I wouldn't suggest this because it's so nice to be able to read your program a lot easier, but you can do it that way so that you can, especially on the calculator. But notice how those are two different statements, and they were separated by this colon.
Mm-hmm. The other thing was the request box. Every time it seemed to run, there was a value already stored in there, and we talked about there's a way to make it show up blank. You just have to put those commands kind of at the end of the program.
Here it is right here. If you put delete variable, where it's going to store the answer, if you put that before the statement, then it'll come up as a blank box instead of a number in it to start with. Sometimes I put a number to start with so that the program won't crash if they accidentally don't put anything in. because that's the other big thing you have to learn how to do, is make your program so that it's literally will not crash. And there are all kinds of